Absolutely not. That's a great question. It's not. We use prerequisites to make mixed ability groups.
Oh, nice. Very nice.
So after you've picked your 10 words, you can turn the page and record your words on page 2. We have not looked much at the data yet, but 2 semesters ago, we did not assign groups randomly, or by mixed ability, so we assigned them based on gender and a personality quiz that we took at the beginning of the semester. But yeah, so that's some data that's currently being looked at. So we would pretty much have students work through number 5, and then as they answer number 5, or after they have an answer to number 5, we would say, come up to the whiteboard and put your answer to number 5 on the whiteboard, which is the doc cam in this room. You guys might not know what 3 and 4 are, so maybe talking to your group would help with that. Absolutely. We have not had that. We have wanted to look at that and measure that, but we have not had the opportunity. So we have 25 sections typically, and 18 to 20 of those are taught by grad students who only teach one section. So that's our difficulty. Right. Right. And so that's the 0.0014 is like just a two sample one-sided p-value for the difference. When we looked at a logistic regression that looked at instructor effects and that kind of thing, that's when our p-value is 0.14, 0.12. To the TEAL. When it first started, it was volunteer. I'm trying to think. Since then, we have, I think it was volunteer until we told everyone you're doing active learning because of what we're seeing. Mm-hmm. All right, what were you guys thinking about observational units?
Observational units are the words?
Yeah, good. Do you guys have an idea about one of the variables that you recorded? Number of letters, okay. And whether it has an E or not. Excellent. All right. So my non-stat people have an idea about the observational units?
I think so.
Yeah? What were you thinking?
The words, right?
Good. Excellent. Perfect. Okay. So again, once you guys get your answer to number 5, the average word length of the 10 words in your sample, we'll have you come plot it on this fancy-dancy overhead projector. Doc cam. I know how to switch it.
Oh,
Yeah.
it's not turned on though.
I think so.
Is it?
Mhm. Okay, perfect. There we go. Ooh, this is fun. Our .cam is like overhead. So any idea on the observational units here?
10?
10 what? What did you record 10 of?
Words.
Excellent, exactly. So words would be our observational unit then. So again, once you guys have your answer to number 5, come up and plot it on the .cam.
So why do you say category of 10? It is only a portion of the population.
Yep, just a dot.
Measuring.
Roughly at what you got. That looks good. During a lecture, but as far as a teaching demo goes, one thing that I think is really helpful in these active learning environments and these technology enhanced rooms is to kind of have a give and go with students, so it's not like they're just working for the entire amount of time. So we do what I call checkpoints. So we'll check in. So this is one of the questions that we would check in at, and I would check in not just on this question, which is leading us into number 10, but check in on a few of the questions before that. The other thing that I like to be able to do is kind of do a give and go as well in small groups. So you guys have heard me. I'll walk around and ask questions and check in and make sure that we are understanding the material and answering questions correctly, because what's the point in having these activities if you're not doing the work correctly as you're doing it in class? So checking in with the students, checking in with the tables, and then also having class discussion. So kind of trying to break it down into 3 different stages of communication with the students. So this would be a point where I could check in. Do I have any other sample means that I could add up here? 6? 6.6. We'll call that there. Okay. Okay. So this is a good point where I would start talking about sampling distributions and making sure that we know how to label a plot. And what type of plot is this? Because we've just worked with that last week. Well, this is a dot plot. How would we label this? Like, what would our x-axis label be here? So I'll ask you guys that. What would I label this x-axis on this plot? What are you plotting from each of you? Yeah. We're plotting a mean word length. So just talking about what we're plotting is a good start for that. Now, this mean word length, would these be statistics or parameters? And why? Yeah, because they're just from a sample, right? They're just the 10 words in the sample. So we talk a lot about what does one dot on the plot represent? What is this one dot representing? And so really labeling that and discussing that, because we're looking at a statistic or the average from 10 words, because those 10 words are a sample from our entire population. Now, what would the population be here? The entire address. Good. So that also gives us a chance to discuss the fact that populations don't mean, like, first of all, a group of people. Here we're talking about words, not people. Second of all, it doesn't need to be some massive, it's not every word in the English language. That's not where I'm taking my sample from. I'm taking my sample from the Gettysburg Address. And so my population then is the Gettysburg Address. So we're able to identify some of those nuances with a population that are common misconceptions among students just by going through this activity. And so we talk about this. The statistic is our average from 10 words. We would plot mean word length is what we're plotting on our x-axis. What about our y-axis? Anyone want to raise a guess there? Like, I have 2 of these. So we would label this as either like a count or frequency. How many samples had that statistic? And so again, we're getting to review some of the material that we had previously covered in the class. We're adding some of these ideas about statistic and parameter and population and sample. For those of you that have gotten to number 6, it says the average word length of the 268 words in the entire speech is 4.29. Is that a parameter or a statistic? That is a parameter. And so I kind of will draw this in as, well, my parameter, and I would write this notationally, that our mu, our population mean, is 4.29. So can we kind of see where this activity is going already? Yeah. What's going to be the point of this activity? So far, at least. What do we notice about this distribution? That we're shooting high. Yeah. Yeah, that we're tending to shoot high, that we're tending to overestimate our parameter here, okay? And so we have a name for that, and that's what you guys will get to in just a minute. When our samples, when our statistics tend to over or underestimate a parameter, we call our sampling method something. And so that's our big picture idea here. We'll see how that works a little bit more in just a minute. So I'll let you guys continue to work through, and then at 17 or 16 will be our next check-in point. Thanks for coming. I'll add, for time's sake, we typically skip the E word questions. So you can skip that E, like number 7, 11B, those kind of questions. I would also encourage more out loud instead of telepathic discussion if this were my classroom. But I'm not going to do that. By like coming in and talking to them and then letting them work on their own kind of thing. So I'll talk to like a team of 3 and then I'll talk to the table as a whole kind of thing. I think I'm also used to a class of 63, so this is much quieter than what I'm used to. So any thoughts on 9? Do you think the words you selected are representative? Okay, why?
Because 50% of my words had E's.
Okay.
And 0.47 is what I said it had. And I had 4.8 for the letters and 4.29 was there.
Good. So because your statistics were kind of close to your parameters, you felt like you were representative. What about you guys?
Picked all the big words.
I didn't, but my proportion of E's was much greater. I had 8 out of 10 E's.
Good.
See, when I
Good.
select a representative set of 10 words.
Exactly. So that also leads us into talking about what that word representative means in statistics. That representative doesn't mean like representative of the context of the story. It's representative of the variable of interest.
Which we did not know at that point.
Which you didn't know at that point, yep. We like to make students do things wrong so we can tell them, you're wrong. Here's the right way to do it. Were you guys thinking your 10 words were representative of the population?
Oh.
Not at all? Why not?
7.9.
Because then
Good.
people must sit in this room, and that's how we answered number 12 and 13.
Okay. Which was that what?
That I feel like I'm biased.
Okay. To over or underestimate? Good. Excellent. What about this plot tells you that we're biased?
Because we're on the high end.
Yeah, most of our statistics were above the parameter. Perfect. Okay. So, how are we doing? Were we pretty representative here? No? Why not?
We're all picking the cool words.
The cool words.
Does.
Good. Good, exactly. So that is something that we bring up with our students. We like to have our students be wrong first and then teach them that they were wrong. So representative in statistics doesn't mean content. It means like of the variable of interest. So that misconception being corrected can help them a little bit.
I mean, I was, if I were asked to pick 10 more, it would just been like more of the same.
Yeah, more of the same stuff.
It was 20.
Like dead and concentrated.
Good. Good. Okay. So what were you guys thinking on 12? What does this distribution tell us about our sampling method? If you were there yet.
Well, based on those numbers, I would say it's biased because we're not, most of us aren't getting close to.
And most are over.
But that could
Excellent.
also be like James' issue with the representative, because like if you were to read this and representative as like what makes the Gettysburg strike us what it is.
Right.
We're not
Right.
circle 2.
Yep.
And
And so our sampling method was not representative. It was biased. We tended to overestimate. Good. Okay. Okay, we can do another quick whole class check-in. I like to do the whole class check-ins. Actually, I typically like to do the whole class check-ins because this is like our break point in the class time. So what does this plot tell us about our sampling method? That it's biased. Good. This plot tells us that our sampling method is biased. How do we know? Yeah, because most of our statistics, the vast majority of our sample means, were above the population mean. So that is our definition of bias. Bias means that our statistics will tend to be larger or smaller than the population value, than the parameter. So what would this plot look like if it were an unbiased sampling method? Good. Bell curve centered where? At the parameter. Good. So we would want to shift all these down to have a nice distribution around the parameter. We should get about a 50-50 split of our statistics over and underestimating the parameter. The other thing that we could talk about with this plot is, did each of you get the same sample mean? No, clearly not. Our dots are all over the place. And so that leads into the idea of sampling variability, that the population mean is the same for all of you because the population is unchanging. And so that's a big idea, that our parameter is a fixed value that's unchanging. But we only see what's happening in our sample. And so we're not seeing this big population value. But this is an artificial situation which helps us understand bias and helps us understand sampling variability, that our statistics vary between our different samples. A couple of questions that I like to check in about. So bias is a big idea from this activity. If we were to take 20 words instead of 10, is that going to help? No. Okay. So a lot of students will say, well, I'd run out of long words. So it'll help, because then my mean will be lower. Good point. Fair point. Your mean will be lower. So do you think the mean is now going to be below 3? No. We're still going to get most of our means above, say, 4.5, which this analogy works extra well this semester. I say bias is like pregnancy. Like, you're not kind of pregnant. Your sampling method, it does. It works well this semester. Your sampling method is biased or it's not. So even though, yeah, like it might be closer, like the center of our distribution of statistics might be closer to our parameter, but it's still not centered on the parameter. We're still tending to overestimate. And so we still have a biased sampling method. So bias is referring to our sampling method, not the sample itself. And so getting that idea across, which is a big idea. So sometimes they struggle with that. The other thing that I like to talk about is 15, which has a lot of misconceptions. So if you dropped a pencil on your paper over the Gettysburg Address, is that going to be unbiased? No. I get one no. Anyone else? Yes? I get a yes. I like having yeses and nos. I like having that discussion. So why do you think that would be unbiased?
Dropping a pencil over the Gettysburg Address to find
Yep.
the words that you're going to say?
Yep.
It's random.
Okay. Okay. So we might need to move it around. Okay. So some students might want to say, well, maybe words in the middle are going to be more likely to be picked than words on the edge. Maybe. Was that your point in saying no? Who said no?
We're still going to pick longer words
Why?
because they're bigger. They take up more geographic space.
Exactly. Which leads us again back to the idea of representative that was discussed with a few people earlier. So that idea of what is representative, students like to think of the word representative in a colloquial, like representative of the context that we're talking about. That's not what representative in statistics means, which is why statistics can be very difficult for students, because what words mean in statistics, random, is meaningful in statistics, not like, oh, I just went and like met this random person for lunch. That's not random, what we mean by the word random. And so getting them past that, what they perceive as what random means or what they perceive as representative, is important. So if we're talking about word length or whether the word has an E or not, well, word length is directly related to how big the word is on the page. That's going to be a bias sampling method. How would that influence whether the word had an E or not? Do you think it would be representative of that variable? Yeah, longer words are still more likely to have an E. So we still are having this non-representative, this bias sampling method, even with something that they would like to think is random. And so we get them to think about some ideas. We typically, if you turn the page, the big idea is use a random number generator. And so that's what we are going to go into next for a little bit. So use a random number generator and see what happens. But we usually have some really good ideas generated out of these open-ended questions. So something that has come up every semester actually in my classes is, well, I need to pick 10 words and there are 270 words in the speech, so I'm going to pick every 27th word. Awesome. Perfect. That's called systematic sampling. That's not something that we necessarily discuss, but it's a great leeway to talk about extensions beyond what's necessarily in this class or what's necessarily in the book. We have people talking about drawing it from a hat. Okay, if the paper is all the same size. Because again, otherwise you have the word length issue and how much space it's taking up in your hat. So we get to some good discussions about randomness and how to actually generate randomness, and really that, like, humans were terrible generators of randomness, and kind of why that might be the case. But the next thing we get into is this idea of taking a simple random sample. I'm going to take this back. Let's see. Ha! I figured it out, I think. We'll see. Laptop VGA? No, laptop HDMI. That's my problem. There we go. So I'm guessing you guys don't have computers here, but we ask students to bring computers, 1 per group, every day. So 1 per group of 3, and then they can argue over which group of 3 gets to plug in and fight about that a little bit, or they can rotate if they're nice. I have not had any trouble at all. In fact, the data visualization software that we use, Tableau, it's not unuser friendly, but it takes a bit of time to get used to. And so we recommend the first 2 days of class for everyone to bring their laptops if they have one, and we don't have an issue with that at all. Almost every single student has a laptop. The applets that we use actually work on a tablet or a phone as well. And so if students don't have a laptop, or if, say, the person who's supposed to bring the laptop doesn't show up that day, we haven't had an issue with that. The other question that I was asked earlier, just in case other people are wondering, I said we use Teams. Oh, I don't know if I can connect to the internet. Let's see. I can pull this up really quickly, maybe. In our teams of 3, the way we set our teams of 3 up is to use the prerequisites. So we can grab a list of prerequisites before students start the class, and we make mixed ability groups based on that. So we have students that, we have a very wide range of students taking our IntroStat class, from students who are just coming out of like pre-college algebra, like 096, 098 kind of thing, to students that have successfully passed Calc 3. So we've got a wide range of mathematical ability coming in. We'll pretend that we've read that. Looks okay. Looks all right. So, so that's how we start. Those are not always great indicators in a stat class. We have some students that are weaker in their math background that do really well with reasoning, and that's a huge component in a stat class, is being able to reason through and use language appropriately. But it gives us a good starting point, and we typically tend to have at least 1 to 2 really strong leaders at each table. which is important. So even if it's not within each group, at each table, we've got a pretty strong group of, or at least one or two strong groups of strong individuals that can really lead their table. I would add to that, there we go, that our students have actually, I've seen a really, honestly, phenomenal job among some students of working with and explaining to other students the content and the important messages and, oh, here's what we should be getting out of this, ideas. And so that teaching, like seeing students teach other students in class is just so rewarding, I've found. So anyway, moving into this activity a little bit more, these applets come with our textbook. They're free. They're just online. So if you're interested, Rossman Chance, ISI applets. But they, or students, I should say, will go to the sampling words applet, and it automatically has the words already in here. So these are our words of our Gettysburg Address. And then you can choose to sample and say, I want to sample just one sample, and I want to sample 10 words. And here's where the technology enhanced part comes in. So this is now a discussion that we have with each table as they have their screens projected of, let's make sure we understand what we're plotting. So what is this a distribution of? So I'll ask you guys that. Like looking at this, it's labeled population data. What is this a distribution of? And then I'd ask, what's the x-axis label? Length. Good. So what am I plotting here? Good. So I'm plotting the length of each of my 268 words. So this is a distribution of the population. So it gets us back to talking about different types of distributions. So we're not working with a sampling distribution here. This is the distribution of my population. This is the distribution of the 10 words that were randomly selected in this sample. Students actually go to a random number generator, which is part of these applets. And then if you guys flip to the next kind of page under 17, I won't make you go through 17, but they are asked to use a random number generator to generate 5 numbers, and then it lists the Gettysburg Address by word number in the address. And so that's how they can figure out which 5 or 10 words they were supposed to randomly select. And then we go through that exact same process that we did back in number 5 and 10, where they calculate the average word length for the 10 words that they were chosen, or that were chosen for them. Mine would be this 5.1. So what are we plotting here? Well, we're plotting our sample. So this is the population. This is our sample. The blue dots tie into the blue dots. So these are the 10 words that were selected for this sample. And then we think, okay, well, back in number 5, what did I plot? I plotted my mean word length. And so I'm taking this 5.1, and I'm plotting this on this third distribution. So we can see the technology and being able to check in with groups is really important because we have 3 different distributions here, and so it's really important to understand what we're plotting in each. And so something I would ask them is, okay, which distribution is most like the one that we created in number 10? Well, what am I plotting? I'm plotting length of my population of words. I'm plotting length of my sample of words. Here's where I'm plotting average word length. That's what I was plotting originally. So this is going to be the equivalent of our class data of what we saw. And so they can plot a few more. Let's draw another sample. Here you can see what 10 words are selected, where those 10 words show up in the population. Here are those 10 word lengths plotted. The new mean is 5.0. And so now I have my new sample, so that's why it's called the most recent sample. So I have my new sample mean and my old sample mean. And fun fact about these applets is they're also interactive. So I can click on my other sample mean, and it will show me the words that came from or that created that sample mean. So you can click through and see your new samples. We'll have them make a few different samples by clicking Draw Samples. For some groups, this is the other thing that is nice about this active learning classroom. If you happen to put a group together that was not mixed ability and you have some of your top students in that group, you can talk about this stratified and cluster sampling. So you can extend their thinking or extend their learning for those groups that are ready to receive that knowledge. And maybe gloss over that because those aren't part of your course with the students that need some more time understanding what we're plotting. But these applets can create more than one sample at a time. This would be their first introduction to these applets, but we will use these every day in class for the entire semester for the most part. So different applets, but for the most part, this is what we're using. And so now we can see what a distribution of, this is 1,005 instead of our 11 samples that we had, but we have 1,005 samples, and we have a variability of those 1,005 samples. We can talk about the center of those 1,005 samples. We can talk about the shape of our sampling distribution. Those are all things that we would have discussed in the previous week, talking about descriptive statistics. Again, you can play around here and see where that sample mean came from, and it labels it. So this was sample 65 and sample 730 of our 1,005 samples. But big ideas here. What do you notice about the center of the distribution? It's very close. Why was the 4.29 important? Where did that number come from? That was the actual mean word length. That was the value of our parameter. Exactly. So we see here that we have a sampling distribution centered on the parameter. What does that tell you about the sampling method? That it's unbiased. Ah, big picture idea. And so they're seeing all this, but you're doing all those check-ins with these students. And it's important to go back at the end of the day and say, now look, in real life, we don't know that number 4.29. We have no idea what unless it's like this, a finite population where we could calculate it. We don't know the value of the parameter in 99% of real-world situations. But from this artificial situation, we've learned that a simple random sample should be unbiased or should be representative of the parameter. We should get a statistic that's close to the parameter. Other leading things to bring up, are all of our samples close to the value of the parameter? No. We get some samples with a mean of 2 and some samples with a mean of 7. Okay? So you're going to have unusual samples. You're going to have samples that even though you did everything right, that's called a random error, where we have samples that end up far from our population value. And those will lead to mistakes we make in statistics. And that is something that I bring back right now. Actually, we just finished last week talking about type 1 and type 2 errors in power. And so this is coming back. I bring up this app again and say, look, remember this? We did this 7 weeks ago, 5 weeks ago, whenever the semester started, and we had some samples that were far from the statistic. Those are the ones that lead to these type 1 and type 2 errors. And kind of, so we can have that connection and that flow from something that we did on day 3 in the class to something that is a higher level conceptual idea of significance level and type 1 error and type 2 error and the power of the test. And those are bigger, more complex ideas than just, look, our distribution is centered on the parameter. It's unbiased. We have a sampling method that's unbiased. There is one more idea that's covered in this activity. So they write down the mean and the standard deviation here. They go back through and say, okay, well, what if I took 25 words? Here's my new distribution, where I have 25 words that were selected for each sample. So this is 1,000 samples of 25 words, where I'm plotting the mean word length from each. What do you notice about the mean? Still at our parameter. So we're still unbiased, okay? Some students will want to say, well, that's even closer because it's 4.29 instead of 4.3. Okay, I'll give you that. It is 0.01 closer. Let's think about that in terms of going from 2.7 to 6.3. It's 0.01 closer. So that gets us into, so did sampling method affect whether our, did sample size affect whether our sampling method is biased or not? No. A larger sample size was still centered on the parameter. And in fact, we talked about that previously when we said if we went from 10 to 20 words that we were picking, that it would still be biased. Same idea. So increasing sample size has no influence on bias. That in statistics is a common misconception for students. Something that is very difficult for them to grasp. They think, well, if I collect more data, it's better. Well, it's only better if you're collecting it appropriately, if your sampling method is good to start. They would have already written down that standard deviation, but I promise the standard deviation is less than what it was previously. And so we talk about, well, what did sample size change? It changed the standard deviation, made it lower. So it's changing the variability between samples. Talking about the standard deviation on this graph versus the standard deviation on this graph also allows us to talk about individual variability, the variability in the word lengths in a sample, which is unaffected by sample size, as compared to the variability in the means from many different samples. So we're getting into a lot of big ideas. This sample size idea, what is sample size going to affect? That's going to come up once a week minimum for the rest of the semester, because it comes up when we talk about confidence intervals. It comes up when we talk about power. It comes up when we talk about generalizability. Can I generalize the results of this study, which is kind of this activity as well. So these are all big ideas that were being introduced early on because we're able to use technology, because we're able to show them what is going to happen in the long run. And again, just that back and forth of working with students in that small group setting, in a table to make sure they're understanding these three distributions, and then the whole class discussions at the end where we're wrapping up some of those big ideas. So I don't want to take our time wrapping up those big ideas, but my notes, if I were to give this lecture, would be going through these things. Okay, so sampling frame, that's something that we didn't quite hit on, but it's our list of observational units. Hey, you were given a sampling frame in this activity. Where's the sampling frame listed at? Yeah, it's that big long table. That table was your list of words in the population. That's a sampling frame. So it allows us to give them an example of that. Talking about a simple random sample and how that differs from a convenient sample is something we would spend some time on. Redefining, once again, what bias is and what unbiased means, that we're producing sample statistics that are representative on average of our population or similar to the parameter of interest. Generalizability, so scope of inference is a big learning outcome for our class. So talking about generalizability and what group can we generalize these results to. That's something that we start hammering from day 3 in the class, day 4 in the class, I should say. And then this idea of sampling variability. So we talk about the fact that variability is the maybe most important thing to understand about statistics, and being able to distinguish between individual variability and sampling variability is a difficult concept for students. And so we get started with that right off the bat. So that way they can start working through these questions. A lot of times we'll ask them to, in their groups, write out an interpretation of that standard deviation that they looked at, that standard deviation of 0.395. What is that the standard deviation of? What is standard deviation in general? So really emphasizing that idea of variability. Do you have a question? Yeah.
I was just wondering if I didn't want to interrupt.
No, no.
So, for example, in a class, you might have people. I often have to present, right?
Mm-hmm.
And so, I was just wondering how you work it out so that you have students
Great question. So our classrooms are set up a little bit differently in the fact that we have whiteboards everywhere, all the way around. And so I typically, honestly, start a class with, let's go over number, one person from your table, write up number 24, which is the impact of sample size. Write up your answer to number 24 on your whiteboards. And that is on the board before they come into class. So the 5 minutes before class even starts, they should be already out discussing these activities in their tables and then writing up an answer. I actually hand out the marker specifically to different people. So you are the spokesperson for today. You are the spokesperson for your table. You are the spokesperson for your table. Not just to not have the same student that gets it write it up, but you also then have someone that's like, you guys better give me an answer because I know I need to write something up on this board and she's going to call on me. And so it increases their accountability to each other.
So in here, we could, because they have phone, they have a device hooked up to the table, they could project to their own. So they
Right,
could
you guys have...
construct their own thing here instead of using whiteboard.
Yeah. Oh, they could, if they're on a computer, they could type it up. Do these connect to like doc cams as well?
No, just
Okay. Okay.
screen, but still you could put it up on the screen.
Right.
Or you have to do one per table. There's right, Dan, there's one access.
There's one.
But that's what we do. I have it one per table written up a lot of times. The other thing I'll do is I'll separate out. So there were 5 questions that maybe we didn't get to cover at the end of the previous class, or to start the activity for the next class, like the RAT questions that I want them to review, and I'll assign one to each table. So you guys answer this question, 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 and then we start class by going around. Okay, tell us what was your question and how did you answer it for each of the groups. So 95% of classes, they're writing something on the whiteboard before class starts. And we're taking the first 5 minutes of class to talk about that, and it gives me an opportunity while they're writing to come around with my marker and be like, okay, so here's some things that we need to fix, and this is, we need to adjust this language just a little bit to include a population word, or those little, what I would call ticky-tacky things that students think are unimportant in statistics, like whether they're using the word population or sample, that are actually really important. So those are things that I can correct and go around and work with students on while they're doing that, while they're writing that up. We are fortunate at MSU with the, I'll call it an abundance of admissions right now, of students right now, that we have some additional money to hire undergraduate aides in the class. So I have, in my class of 63, I'm in there with 2 undergraduate aides that took and passed, were A students in Stat 216 last semester or the previous semester, that then come in and they can come around. We check that they've completed their explorations, like did you complete 1 through 25? 2, 1, 0. Yes, we did it. We did about a half of it, or we didn't do it at all, kind of thing. And so they get grades based on that. It's more of, than anything, a proxy for attendance. That is honestly one of the biggest things we saw in the change in success rates was the change in withdrawal rates, because students are in class. If they're there, they're absorbing some information at least. They're doing something. Right. Right, whether they like it or like they're taking in something, they're literally actively working on a problem for 50 minutes. You have to take in something. And so they're less likely to withdraw when we have those essentially attendance scores. It is a small grade booster for them. As long as you're in class, you're getting points for that. So it's not a huge part of their grade, it's 5% of their grade, but they think it's worth more. Yeah.
So in terms of your actual testing then, do you do paper pencil tests, or you do it's all on Moodle, I mean, it's all electronic?
So the RATs we do on Moodle, our weekly assignments, we alternate between quizzes and like written out assignments. Everything's turned in online though. So the quizzes are through Moodle. I'm not familiar with Moodle, but we have like an assignment Dropbox essentially, and then I can grade those online. So the only thing that we paper hand back to them are exams, which makes it sometimes it makes it difficult to learn students' names because you're not physically handing stuff back to them every day. So that is a difficulty. It's in this active learning classroom, it's easier to walk around and get to know people as you're doing that, as long as you're putting in the effort to do that. But it can be easy to get lost if you're not handing back things, I've found, to lose track.
But they always sit in exactly the same place, so that's gonna help.
They do sit in the exact same place. We change groups after each exam based on the exam scores. So again, we use the exam scores and attendance scores essentially to recreate mixed ability groups. I mean, we only give 3 exams, 2 midterms and a final. So yeah, absolutely, thanks for coming. So it's every 5 weeks that they change.
Which is actually good.
Mm-hmm. Right, we get a lot of negative feedback on that when they have to leave their first group. A lot of students get really attached. We've got students that come out of Stat 216 with like a new best friend. It's crazy, it's weird. I've had relationships start in my class based on groups. Yeah, it's interesting. Yeah, it's interesting. But I'll just add, so we talked about these key ideas. Some things that we have found that are difficult in this environment is instructor comfort level. It is a lot easier to do this for 30 minutes and never see your students, or 50 minutes, or however long your class is. And so it takes some time, especially for me working with grad students, it takes some time for them to feel comfortable, one, to let the class go, to not stand up here and lecture through everything that they should have read already, or else they're not gonna read it. They're gonna guess their way through the rat and not put in the time. And then if you're taking 30 minutes going over the material that they were supposed to come to class prepared with, they don't have time to work through the questions. And so we're losing that flipped environment, that active learning environment. So one, being comfortable letting go and being okay with the students having to have some accountability. And 2, walking around and not just looking over shoulders and answering like, yeah, that's right, or just checking work, but checking understanding as well. So getting comfortable with not just what was your answer, but why did you answer that way? Why is that a statistic? Why is that a parameter? Why does this show that our sampling method is biased? So getting into those whys, and also, again, working on student names by calling on the students. So you might ask a group just a general question, what did you answer for number 5? Okay, Jane, why did you say that was a statistic? And then that helps you identify as well, I feel, students that aren't understanding the material as well. And so you can work with them a little more closely, keep track of them a little more closely. And then students, this is more a flipped classroom, but I get a lot of student responses of, I pay blah, blah, blah amount of money, and I really want to say, your parent pays blah, blah, blah amount of money, and I don't learn anything in class. I have to do everything on my own. Yeah, welcome to the real world. Like, you do. You need to be responsible for your own learning. And so this is the number one thing that we battle. And the more you work with students, I think, early on, with seeing the benefits of this active learning approach, the less you get of that. For the most part, we have a very small percentage of students. I've got maybe 2 to 3 students, like I said, out of 800 to 900 each semester that are just dead set. I don't work well with others. I don't like to talk in class. I won't do group work. Okay, you're gonna have a very tough life if you're unwilling to work with others, but if that's your decision in this class, we'll put you in this group where there are 2 other people that tend not to show up on the next 2. And that's our compromise with them. I know, it's not a great compromise for us, but if they've gone through 6 weeks of the class and hate it and refuse to do anything. What I found is continuing to force that issue ruins the environment for the people around them. And so it's easier to let those 1 or 2 students have their way and say, okay, you can primarily work on your own. I'm still going to check in with you. You still need to be here. You still need to do the work outside of class and work on the questions in class. But I don't want you to spread your negativity to the other 8 people that I would have sitting with you, who are otherwise positive about this experience, or at least neutral, and not frustrated like you are. On the bright side, we've seen a lot of really good things. Student engagement, the connection, like I said, it can be difficult, at least I find, to learn students' names because I don't hand anything back to them. Unless I collect, sometimes I'll collect like exit tickets or something like that to check in on understanding and then give those back so I can help learn names. But even without knowing names, I teach a 310 class and I've got 3 students that will sit after at from 4 to 4:30 or 4 to 5 whenever I'm ready to leave campus, and they'll just hang out in the classroom and do their work in there and check in with me and ask questions and come up. I have far more students coming to office hours than I did before I taught in an active learning environment. So that has been really nice to see. Like I said, we've got great connections occasionally between students with relationships starting, friendships beginning, but they can get very tied to their first group that they're with, depending on if it works well or not. Statistics is a language. We talk about that in a lot of our class, and so that ability to communicate as opposed to a lecture environment. Clearly, better success rates and higher grades as well. So we've seen just a lot of really great things come out of this active learning environment. Like I said, the TEAL room is really useful for us because we use technology every day. We use those applets every single day in class to create a simulation which assumes the null is true and find how likely our statistic is, and ta-da, we have a p-value. And it's not just a number for you, it's not just a strength of evidence. I actually understand the concept that a p-value is telling me how likely my data is if this null hypothesis is true. That conceptual understanding has been the biggest jump we've seen. And part of that is content, like the way we teach the course, but a lot of it is being able to visualize a p-value on a screen with 8 other people that you can discuss it with and discuss, how did we calculate this p-value again? Okay, now I understand what it's really representing. So we've seen a lot of benefits. We really enjoy it. I really like teaching in the TEAL rooms. The other thing I like about it is because we're on the applets all the time, students are more comfortable with this sturdy table for their laptop, tablet, whatever electronic device they're using in class. It's just, it always scares me when I'm in a room with like mobile desks. They're moving them and they're this big and they're trying to have like a notebook and a book and a computer on their desk. So.
Did you see much of a challenge when you went into the bigger TEAL room with the 63 students or whatever?
A little bit. I did, honestly. Part of that was just it was just a fact of having management of more students. Time-wise, it's 50% more grading than a 40-person class for a 60-person class. Students don't understand that either. That's something we talk about. So that has been difficult, and like I said, learning student names in a 40-person classroom is a lot easier than in a 60-person classroom. But in terms of attendance, we have not seen a real difference for the 40 versus the 60-person. They don't get lost, and part of that is probably because we have more than one. Like we have 2 people, we have an instructor and an undergraduate in our 40-person room, and we've got 3 in a 60. Undergraduates are cheap. I think we pay them $10 an hour, or they can take an upper division math class, like a 3-credit math class for it, in which they're paying for tuition and they're not getting paid to help, and it's like, all right, thanks for that. It's a good way to go. Just an idea. So we've got a few minutes, but I wouldn't mind, again, because we're in this active learning environment and active learning mindset, about just talking with the people at your table about some of the things that you were thinking in terms of these TEAL classrooms. How could you efficiently use them? Any content changes or pedagogical changes that you could make in order to make these rooms efficient for what you guys would be teaching in them. I know some of you maybe are teaching in them, but. So I'll let you guys, I'll kind of come around. And so if you have questions for me, I'll certainly come around and answer those. But if you want to spend some time talking about those, talking with peers has been a huge help as well for us, at least.
I run a simulation
Do you?
in my capstone strategy class.
Okay.
We use a computer lab for that. But in terms of walking around, this would be nice. Just because we do it in teams, so one per table would be fine. But in the computer lab, it's rows. We all know
Right.
computer labs, rows, and so it's a bit more difficult to access the students, access the screens. But in here, for our physical campus here, I've limited to 4 teams. The downside.
Right.
Sometimes I have 6 teams and 4. Don't know how I would deal with that quite yet.
Yeah. Are they working on like the same document, basically? The same simulation for their class? Like
Yeah,
the
they're
teams
all-
are?
Yes, they're all
Okay.
working on the same simulation, different teams within the same
Okay. So yeah, you could like rotate who's plugged in and kind of work in there. Yeah.
There's also some secrets,
That they might not want to share.
product pricing,
Okay.
development, design, things like that.
Okay.
They're working on. So we still. That
right.
for me is just a convenience of technology. We're already doing that.
Right. Okay. Okay. What about you guys?
Yeah, in history, I mean, I can come up with ideas of how to incorporate the technology. I already do a lot of the active learning types of activities. One thing I was talking with my colleague who runs the writing center, I see tremendous potential in a space like this for peer review of
Right.
writing and things like that, because they could throw a paper up on the screen and talk about things.
Right.
So.
Well, from the library's perspective, most of the time, if we're lucky, we get into a classroom like one time, so we get like 50 minutes. So what I would envision is, instead of me standing up in front of that room yakking at you and showing you stuff, is that we would get to work as a group, hopefully on some research project that you're doing, and then I can go around and help you when you run into those failures
Right.
that you're inevitably going to run into.
Right.
Yeah, the researchers are really nice too.
Yeah, and especially like as I think as we move towards the more capstone projects where people are going to be more likely to work in groups.
classic.
And
You're really
they're more likely to probably engage in some sort of more in-depth research than
I want to use that.
their freshman writing
That
class
should be
or whatever.
you ever seen that?
I can see that this holding a lot of advantage to that.
Right.
Having those groups work together rather than just facilitating that more than
Mm-hmm.
Right. Exactly.
because sometimes I feel like I'm just talking to myself.
Yeah. As far as like the technology, we use a lot of technology, and so it is useful in that respect, and being able to, pull up the screen and point things out to students. But like I said, we've got those 2 new that are active learning just without the boards, and honestly, the round tables
Yeah.
are huge.
Yeah,
just
having
huge
that.
for facilitating discussion and just having, students have that expectation coming in, like, this is not a class where I'm going to sit, like our tables are round. Some of our students don't even see me. A third of our students don't even see me when I'm lecturing. So it's not,
And that's one thing. I mean, having the screens here, because sometimes, I'll intersperse, I'll do a little bit of lecturing, which for me is mostly putting a picture on the thing and talking about it.
Yeah.
But I could do that more easily, not have them have
Right.
to move to their groups, then move. Okay, now we're going
Right.
to take some notes now and move back to our thing.
Right.
Have you you had resistance from faculty? I mean, how do you get
Faculty buy-in. In terms of our grad students, they don't put up much of a fight.
They don't get to.
Yeah, they don't get to. I would say we would have. We had a couple of faculty members when I was first at MSU that would not have been on board with the way we teach it now. They have moved on, to be honest. They were part of the reason that our success rates were at 60%.
Well, that was going to be the next question, is kind of alluding to my earlier
Right.
question about.
We do. We did, when we started, we had more experienced teachers that were the ones that were more willing to take on this new environment, this new classroom setup.
Steve, is there a classroom?
Probably.